Hi, so in this video I'll be looking at Chemistry 9701, Paper 1, Variant 2, May-June 2017, Multiple Choice. So let's start. In which species are the numbers of protons, neutrons, and electrons all different? So let's write down for all the species the number of protons, neutrons, and electrons. In fluorine ion, the protons we have 9, and then neutrons we have 19 minus 9, which will be 10, and electrons 9 plus 1 since we have a negative charge, so it would be 10. So definitely A is not the correct option. Let's look at sodium now. Proton 11, neutron 23 minus 11 would give us 12, and electrons 11 minus 1 since we have a charge of positive, so that would be 10. This is for sodium. Now for phosphorus, protons are 15, neutrons 31 minus 15 is 16, electrons 15. Since there is no charge, electrons would be equal to the protons. Lastly, we do not need to find out for sulfur ion since we have got the answer. Here we found out for sodium, and all of these numbers are different, so our answer is B. Moving on. Which would contain 9.03 into 10 to the power 23 oxygen atoms? So let's do some calculations. So we know that 1 mole of any substance contains 6.02 into 10 to the power 20 23 atoms, which is also the Avogadro's constant. For all of these options, let's first write down their formulae. So for aluminum oxide, it's Al2O3. For sulfur dioxide, SO2. For sulfur trioxide, SO3. And water is H2O. Now, for 0.5 mole of aluminum oxide, there would be how many oxygen atoms? Let's first do some calculation. That is 0.25 into 3, because there are 3 oxygen in this formula. So 0.25 into 3 gives us 0.75 moles of oxygen. For just like this for all the options, 0.75 into 2 according to the formula, which is 1.5 moles. 1.5 into 3, which is 4.5 moles. And lastly, 3 into 1 will remain 3 moles of oxygen. Now you have got the moles. Now what you can do is, since you know that in 1 mole there are these many atoms, so in how much, or in all of these moles, will there be oxygen atoms? So you can multiply all of these by 6.02 into 10 to the power 23, and you can find out the answer and match it. So I'm just going to write down the answer. A gives us an answer of 4.5 10 to the power 23, and B is giving us an answer of 9.03 into 10 to the power 23, C 2.7. So you don't really need to do all the working since we have already got the answer, which is B right here. So our answer is B. Moving on. In some fireworks, there is a reaction between powdered aluminium and powdered barium nitrate. heat is evolved, an unreactive gas is produced, and all nitrogen atoms are reduced. So what is the equation for this reaction? Since we know that an unreactive gas is produced, it is much likely that it would be nitrogen. So this equation and this equation contains nitrogen. Now let's try to, these ones are cancelled. So let's see which is going to be the equation from these two. Since they have told us that all the nitrogen atoms are reduced, and we know that here nitrogen has a oxidation number of 0, meaning whatever the oxidation number here was, it has all reduced to 0. So, but in this equation, some of the nitrogen is in the form of this compound. That means not all nitrogen are reduced. Hence, the answer would be C. Which organic compound has the highest boiling point? So let's look at these compounds. So this is just a normal organic compound with methyl groups attached. CH3, CH3, CH3. It has really compact shape. Let's look at all the other ones. This is also but it is in the linear form. So this in B, this halogen will be having a higher boiling point than A, because surface area of B is more than surface area of A. In C, there is, as you can see, it is a carbonyl compound with this bond. Okay, and then D, there you can see is hydrogen bonding. Hydrogen bonding is what hydrogen attached to either nitrogen, oxygen, or fluorine. So here hydrogen is attached to oxygen, so there is hydrogen bonding. That means D will be having the highest boiling point. At a temperature of this and a pressure of this, a sample of 0.321 grams of sulfur vapor has volume this. What is the molecular formula of sulfur under these conditions? So the formula is pressure into volume is equals to moles and constant R, which is the molar constant, and temperature in Kelvin. So make sure you are putting in all the values in their specified units. So let's write them. We need to find out the moles first, then we can use those moles to find out the AR. So moles, let's make N the subject of the formula and put in the values. N is equals to pressure, which is 1 into 10 to the power minus 4, and volume, which is in meter cube, and that is the right unit, 2.08 into 10 to the power 6 over 8.31. You can check the value of R from your data booklet, into 2500. Always write temperature in Kelvin for this one, and doing the calculation you will get N's value as 0.01. Now you can use this number of moles to find out the AR. Mass is given as 0.321, 0.01, and AR is coming out to be 32.1. Now we know that this AR belongs to sulfur in this state from the periodic table. Which reaction involves a decrease in the bond angle at a carbon atom? Monoethane be flexed with ethanol sodium hydroxide. So this A is the elimination reaction where haloalkane is changed to alkene. So there is increase in bond angle from 109 decrease to 120 degrees. Since haloalkane, a carbon is regularly bonded to 4 atoms of hydrogen or a halogen, and ethene, it is in a trigonal manner. Now in B, complete combustion of methane in air, it produces carbon dioxide. So from methane, carbon dioxide, there is a increase in bond angle of 109 degrees to 180 degrees. Since again in methane, a carbon is tetrahedrally bonded to 4 hydrogen atoms, so 109 bond angle, and in carbon dioxide it is linearly bonded to 2 oxygen atoms, making an angle of 180 degrees. In C, ethanol heated with concentrated H2SO4. Now this is also a bond angle increase from 0.9 degrees to 120 degrees because ethanol changes to ethene here again, same as A. And in D, polymerization of ethene, this is actually a decrease in bond angle from 120 degrees to 109 degrees because in ethene it is an alkene having a double bond in between, so 3 atoms hydrogens are connected to one carbon, making an angle of 120 degrees, but in polymer formed after addition reaction, the double bond will be broken and all the carbons are bonded in a trigonal, actually tetrahedral manner, so the angle will decrease. In high temperatures of car engines, nitrogen reacts with oxygen to give nitrogen monoxide. This reaction has operation energy EA, which reaction pathway diagram to correctly represent this reaction. So from this phrase high temperatures, meaning heat energy is required for this reaction, meaning this is an endothermic reaction. And we know in endothermic reaction, the products are at a lower level than the reactant. Oh, actually, the reactants are at a lower level than products. So which diagrams to make this diagram is clearly wrong because product is at a lower level than reactant. This is not endothermic. Now all the other diagrams show that reactants are on a lower level, which is right. Now we are going to look at EA. In B, EA is shown just once, so this is wrong. EA is going to be the whole of this, which is here, this is right. The arrow pointing down is wrong. And now we will change, this is right. This is also right. So everything shown in C is right, so our answer is going to be C. Question 8. A reaction sequence is shown. In each stage of this sequence, the sulfur is oxidized, reduced, or neither oxidized nor reduced. Which row is correct? Okay, so for this, you just need to write all the oxidation states of sulfur in each of these compounds so that you can easily choose which row is correct. So in oxidation state of sulfur in SO2, it would be +4 because if you take S for sulfur and then you take plus +2, since there are 2 oxygen, and oxidation state of oxygen in any compound is -2. So this gives us, and it is equals to 0 because the sum of oxidation is always 0 of a compound. So this gives us an answer of 4. So here the oxidation state of sulfur is 4. Just like this method, you can find out the oxidation states of sulfur in all of these compounds, and it would be +6 here and also +6 here. It would be -2 and +4. So now going from here to here, 1 is oxidized, so these are correct, and then 2 neither, there's no change. And then in 3, step 3, it is clearly reduction since +6 is going -2, and then there's again oxidation. That means C is the correct answer. Hydrogen and carbon dioxide gases are mixed at this temperature. A reversible reaction takes place. Okay, at equilibrium, the partial pressures of H2 and CO2 are both 10 kilopascals. Kp is given to us. What is the partial pressure of carbon monoxide in the equilibrium mixture? So since first thing we notice is that the mole ratio is 1, 1, 1, and 1 for all of them, right? That means we can write it as Kp can be written as Kp is equals to partial pressure of water vapors into partial pressure of carbon monoxide over partial pressure of H2 gas and partial pressure of CO2, right? Okay, now you can substitute the values. Kp is given as 0.288 is equals to, you can take the partial pressure of H2 and CO as 1, so x into x over the partial pressures of H2 and CO2 are both the same, so 10 to the power 2. Now solving this, you're going to get an answer of 5.37 kilopascals. A reaction involved in the contact process is shown. The reaction is investigated at 200 kilopascals and 700 Kelvin, and the value of the equilibrium constant Kp is found to be Y. The reaction is then investigated at 1000 kilopascal and same temperature, and the value of Kp is found to be Z. Which statement comparing Y and Z is correct? Okay, so since pressure is being raised from 200 kilopascal to 1000 kilopascal, while temperature is the same, so we know that Kp and Kc are both temperature dependent quantities, and since the temperature is not changing here, the Kp value will remain same, so Y and Z are the same. Okay, the Boltzmann distribution for the hydrogenation of an alkene at a particular temperature in the absence of a catalyst is shown, which row correctly describes the effect of adding nickel to the reaction vessel. So nickel would be added as a catalyst. So what will happen to the shape of the Boltzmann distribution curve? We know that the shape would not change in the presence of catalyst. Shape never changes in the presence of catalyst, but only the activation energy is lowered. So C is the answer. Meaning this EA would be somewhere here in the presence of catalyst. Okay, the elements magnesium and sulfur each form doubly charged ions. How do the atomic radii and ionic radii of these elements compare? So in order to do this without making a mistake, just write down the electronic configuration of magnesium, which is 1s2, 2s2, 2p6, 3s2. Now in magnesium ion, which is 2 plus, meaning 2 electrons are given, these 2 will be given out, meaning the electronic configuration will just be this. Now, since this is showing that the magnesium ion's radius is lesser than magnesium atom's radius because it has 2 less electrons. So magnesium ion's radius is lesser than magnesium. These both seems to be right. Now for the atomic radius of sulfur. So sulfur's electronic configuration is 1s2, 2s2, 2p6, 3s2, 3p4. But sulfur ion will be having electronic configuration with 2 more electrons, so this would all be the same, but this, instead of 3p4, it is going to be 3p6, meaning 2 more electrons. So 1 more orbital is filled up, there would be more repulsion, and hence the size of the radius of sulfur ion would be greater than the sulfur atom. So B is the answer. Which graph correctly shows relative electronegativity plotted against relative atomic radius for the elements? Okay, so these are period 3 elements. Right. So we have to look at the atomic radius. We just did that. Okay, so we know that the trend of atomic radius across period 3, the atomic radius decreases. Because electrons are added to the same shell, and there is increasing nuclear charge, so the atomic radius decreases, which is shown correctly in this one. This is wrong. The most correct manifestation is in this one. And with the electronegativity's trend is similar to ionization energy, since ionization energy increases across the period. Hence, electronegativity also increases across the period. Right, so our answer is most definitely B. Trends are seen in the physical and chemical properties of the elements of crypto and their compounds, which property shows a decrease from magnesium to barium. The rate of the reaction between the element and dilute hydrochloric acid, this property does not decrease. The rate of reaction will increase actually because reactivity increases down the group, because size of the atom is increasing. So the A is wrong. The solubility of hydroxides, this is also wrong, since solubility increases down the group. Solubility of hydroxides. The solubility of sulfates, this actually is the right option. Let's look at D first. The temperature of decomposition of the carbonates. So this actually increases down the group, so this is also wrong. So our correct option is C. Calcium oxide is added to water and the resultant mixture is filtered. The filtrate is X, okay. When carbon dioxide is bubbled through filtrate X, a white precipitate is formed. Which equation of this for this reaction of filtrate X with carbon dioxide is correct? So when CaO, which is carbon dioxide, it is added to water, what is going to form? Hydroxide is going to form. Now this hydroxide is actually reacted with CO2, and this would give us what? A white PPT. Okay, so calcium hydroxide is shown here and it is shown here. A and C are going to be crossed out because there is no calcium hydroxide shown in those options. And a white PPT, which is most probably going to be of calcium carbonate. So D seems to be the most fit answer. Element X reacts with cold dilute aqueous sodium hydroxide to form two different chlorine-containing products, Y and Z. What are the oxidation states of chlorine in Y and Z? Okay, so we have studied this equation of chlorine reacting with dilute NaOH, forming NaCl plus NaClO plus water. So these products are Y and Z. And the oxidation state of chlorine in NaCl is -1, and here its oxidation state is going to be +1. You can check by adding the oxidation states, and if it gives 0, then the answer is right. So our answer is C. A powder is known to be either a single sodium halide or a mixture of two sodium halides. A sample of the powder was dissolved in water. Aqueous silver nitrate was added and a pale yellow precipitate was formed. This tells us the presence of iodide ion. When concentrated aqueous ammonia was... Oh, so concentrated is a very important keyword here. Aqueous ammonia, whenever the word aqueous ammonia comes up, you know the test for halogens is being done. This precipitate partly dissolves, leaving a darker yellow precipitate. So what might the powder be? The answer for this must be D, because for sodium chloride, okay, so we know that chloride PPT is the one that is dissolved, that only dissolves in concentrated aqueous ammonia. None of the other ones, bromine or iodine, does. And sodium iodide, why? Because a pale yellow PPT was formed. So this only one. And why iodide? Because yellow PPT. These are the both indications. Now question number 18. The ammonium ion is formed by the following reaction. Which statement about the species involved in this reaction is correct? The ammonia molecule contains a dative covalent bond. No. Ammonium ion does, but not ammonia molecule. The ammonium ion is a Bronsted-Lowry base as it has accepted a proton. Let's read the other options first. The H in H bond angle changes from 107 degrees in ammonia to 90 degrees in ammonium ion. No, that's not true. It changes from 107 degrees to 109.5. And lastly, the number of electrons surrounding each nitrogen atom does not change. This is actually the right answer, the most suitable answer, because in ammonium ion a dative bond is formed, which is somewhat this. These are the hydrogens. They are one electron comes from hydrogen and the other from nitrogen, but the fourth hydrogen that is attached in ammonium ion forms a dative bond. How? When it is sharing the electrons both from nitrogen. These are both from nitrogen. Hence, the total number of electrons is not changing. These are not changing. Hence the answer, it is D. A chemist took 2 dm cube of nitrogen gas measured under room conditions and reacted it with a large volume of hydrogen gas to produce ammonia. Only 15% of nitrogen gas reacted to produce ammonia. Which mass of ammonia was formed? Okay, let's do the calculations. Let's first write the equation, which is going to be N2 plus 3H2 and 2NH3. This is the equation, and it has been given to us that only 15% of 2 dm cube of nitrogen gas reacted to form ammonia. So let's find out what is 15% of 2, and it is 0.3. So we know what volume of nitrogen gas actually reacted, and we need to find out the mass of ammonia formed. So let's first find out what is the volume of ammonia formed. So volume is unknown, but we do know the mole ratio. So let's use mole ratio, which is 1:2. And we also know that at room temperature, the volume of a gas is 24 dm cube. Here it would be 2 into 24, right? So now, by cross multiplying, x could be found out by 0.3 into 2 into 24 over 24. This cancels out, and we have got the answer of 0.6 dm cube of ammonia is formed. Now, using this, you can find out the moles. So there's a formula of volume is equals to moles into volume at room temperature. So volume is 0.6, moles we don't know, and 24. X is equals to 0.6 divided by 24, which is going to be 0.025 moles of ammonia. And now using these moles, we can find out the mass. Mass is equals to 0.025 into ammonia's MR, which is 17. And the answer would be 0.425 grams. This is the final answer. Moving on. A carbonyl compound X will react with HCN in the presence of NaCN to make a compound with MR85. Compound X does not react with Felling's reagent. Just reading this, you should be able to cancel out some options from these. Since compound X is not reacting with Felling's reagent, it must not be ketone. So butanone is cancelled out, propanone is cancelled out, because ketones never ever react with Felling's reagent. Only aldehyde does. So ketones Now you need to just write the product that will be formed and find out the MR to match the answer. So let's erase some of this stuff. The product of reaction with A would be just these are showing all the H. This is the product of reaction with A. Now you can find out the MR for this. MR, it would be around 83. And for, oh, I made a mistake. I cancelled out aldehyde instead of ketones. Sorry. So, oh, only butanol and propanol will be cancelled out, not butanone and propanone. Butanone and propanone are aldehydes, and butanol, okay. Okay, so yeah, the answer could only be from B or D, since they are ketones, and ketones don't react with Felling's reagent, and that is mentioned in the question. So my mistake. So let's find out the product for these. So the product with butanones would just be, if butanone is this, right? So the product would be in the place of double bonded oxygen, it would be OH and CN and all the H. So the MR would be, there are 5 carbon atoms, 12 into 5 plus how many hydrogen? 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 hydrogen plus 1 nitrogen, which is 14, and plus 16, giving us 99. MR of 99, so this clearly B is not the answer. Let's confirm if the answer is D or not. So propanone would be this, and its product would become then OH, CN, and dimer. There are 4 carbon atoms, and 1, 2, 3, 4, 5, 6, 7 hydrogen, and oxygen and nitrogen, 85. So its MR is 85, so the answer is D. Crenayol and linalol are compounds found in some flower fragrances. Which statement is correct? They are chain isomers of each other. Let's check if they're chain isomers. If the longest chain is different, then they should be chain isomers. So here is this chain till here. This is the longest chain in this one, and this is the longest chain. 1, 2, 3, 4, 5, 6, 7, 8. 8 carbon atoms chain, and 1, 2, 3, 4, 5, 6, 7, 8. So the chain are not different, so they are not chain isomers. They are geometrical isomers of each other, meaning cistrons. Let's check. There is a double bond here, and there's a double. There are totally different groups attached. They are not geometrical isomers of each other. They're optical isomers of each other. Let's see if there are any chiral carbons. There are no chiral carbons in this one, hence they are not optical isomers as well. What about positional isomers? Okay, so positional isomers, it means that the functional group is in the different position. Here the position seems to be same, but this position of functional group is different. Here it is here. Okay, so let's check if they're. The second functional group is on the second carbon. If we count from here, 1, 2, it is on the second carbon, but here it is on the first carbon. So that means the functional group, which is double bond alkene, its position is changed in these, so they are positional isomers of each other. Which equation represents the initiation step of the substitution reaction between methane and chlorine? Okay, so that would be this one, which is the homolytic fission. For example, this is the Cl bonded diatomic state. It breaks homolytically and forms two radicals, free radicals. Moving on, aqueous sodium hydroxide reacts with 1-bromopropane to give propane-1-ol. What should be included in a diagram of the first step in the mechanism? Okay, so a curly arrow from a lone pair on the hydroxide ion to partial positive carbon atom of 1-bromopropane. That's right. A curly arrow from partial positive carbon atom of 1-bromopropane to hydroxide ion. Now this is wrong, because the curly arrow is not directing from partial positive carbon atom to hydroxide ion, because how can that happen? The hydroxide ion has extra pair of electrons, so the arrow will be pointed from it, not towards it. See a curly arrow from a carbon-bromine bond to the carbon atom. No, that's also wrong. The homolytic fission of the carbon-bromine bond, no, there is no homolytic fission. There's all the bonds are broken through heterolytic fission, not homolytic. So the answer is A. A sample of 2.76 gram of ethanol was mixed with an excess of aqueous acidified potassium dichromate. The reaction mixture was then boiled under reflux for 1 hour. The required organic product was then collected by distillation. The yield of product was this much. Which mass of the product was collected? Okay, so for this question, we know that the oxidation with conditions heating under reflux or boiling under reflux will give us ethanoic acid, right? So ethanol to ethanoic acid. That is the organic product that we need. So now we have the mass of ethanol, so we can use that to find out the moles of ethanol. So moles is equals to 2.76 over the MR of ethanol, which is 46, and hence the moles would become 0.06. So we know the moles of ethanol. We can use it to find out the mass of ethanoic acid, since we ultimately need that here. So for mass, we know the moles, 0.06. MR can be found out of ethanoic acid, which would be 60, and hence the mass would become 3.6 gram. So we know the mass of our organic product. We just need to find out the 75% of it. So now the 75% of 3.6 would be 2.70. So our answer would be D. Compound X is a single pure optical isomer. X is heated with an excess of concentrated H2SO4. Only one organic product is formed. What could X be? So let's see how many chiral carbon there are in these. So in A, this is a chiral carbon. This is also a chiral carbon. This is also a chiral carbon. So it's not a single pure optical isomer. So A cannot be an answer. In B as well, these are all chiral carbons. And then in C, this is a chiral carbon. This is also a chiral carbon. In D, let's see if heated with excess concentrated H2SO4, what is going to be formed. Now this, in A, a double bond could be formed here. It could be formed here as well. So one organic product is not forming. In B, it could be formed here or here. So B can also not be the answer. C, here, here. D, there's only one option since OH is attached to this carbon. It is going to be just this organic product where the bond would be here, because that's the only option. So D is most likely to be an answer. Correct answer. Okay, moving on. 2-bromo-2-methylpropane undergoes nucleophilic substitution when heated into reflux with an aqueous solution of sodium hydroxide. Which row is correct? Mechanism for this reaction. So mechanism would be SN1. SN1 because this is a primary haloalkane, right? So mechanism, not primary, sorry, secondary. And the hydroxide ion is helped in its approach to the central carbon by the methyl groups. No, that's not the correct statement. The intermediate carbocation is stabilized by the inductive effect of the methyl groups. That is correct. The hydroxide ion is hindered in its approach to the central carbon atom by the methyl group. That is right, but not for SN2. These are not related. In SN2, that is the mechanism for primary haloalkane. So in primary haloalkanes, there are not many methyl groups, so this statement is not true for SN2. If it was mentioned for SN1, it might have been an answer. The intermediate carbocation is destabilized by the inductive effect of methyl groups. That's not true. It is stabilized, not destabilized. So the answer is B. Okay, so this is the structural formula of 2,4-D and BH. Okay, many but not all organic reactions need to be heated before reaction occurs. Which reaction occurs at a good rate at room temperature? Okay, so in option A, this is cracking, and cracking does require heat, so it cannot be an answer. B is showing the reaction of halogen and cane with ammonia, so that also requires heating. So B is not the right answer. C is preparation of halogen and cane, so that can't be an answer. And D is showing the reaction of 2,4-D and pH. Okay, so D might be a close answer. Carboxylic acid P has no possible chain isomers. It reacts with an alcohol that has only one positional isomer. What could be the ester formed from a reaction between P and Q? Okay, so for butyl propanoate, it must have been formed from butanol. So let's try to draw butanol first. This is our butanol, and it must have only one positional isomer. That is true. Butanol has one positional isomer. This functional group could be attached here, and that is the only other possibility. So butyl is okay. It's following what the question is asking. And now propanoic acid. Propanoic acid is this. It has no possible chain isomers. So the longest chain is this one, and it could not be changed. So that's true. The chain would remain this, whatever. If you're writing it like this, it is still the same. The chain is the same. So that's right. So A can be an answer. Let's look at the other options. For ethanol, this is ethanol, and it has one positional isomer. No, it doesn't have any positional isomer, because if you attached this here, it is still the same molecule. So ethyl cannot be, so B cannot be an answer. What about C? Pentanol. Pentanol is this. Now this OH could be attached to, it could be attached to here. It can also be attached to here. So that's more than one positional isomer. So pentyl cannot be the alcohol. So C cannot be an answer. Propyl, Let's look at propanol. Propanol is this. Let's check if it can have another positional isomer. This could be attached here. So yes, it is. It does have one positional isomer and no other option. So, and let's look at pentanoate if it has no possible chain isomers. So pentanoate would be this. Let's try to change its largest carbon chain. Let's have this. No. If I attached this here, then the chain has become different. This is a different molecule now. This is not pentanoic acid. This is 2-methyl pentanoic acid. So the carbon chain is clearly being differed. That means pentanoate cannot be the part of this ester. So the only answer that could be is A. Which compound is chiral and reacts with sodium carbonate to give carbon dioxide? So it must be carboxylic acid. It must be having carboxylic acid to react with sodium carbonate. So let's see here. This is a carboxylic acid. Does this have chiral carbon? No, no chiral. So A cannot be. Here there is no carboxylic acid. B can also not be. And here there is no carboxylic acid. Again, C is wrong. Here it is. There is carboxylic acid. And there is also a chiral carbon. So D is the correct option. Which compound when hydrolyzed gives propanoic acid and propane-2-ol? Okay, so let's try to make these. Let's do A first. Okay, so this is the ester bond. So the part before the ester bond is the acid. This is our acid, which is propanoic acid. So propanoic acid is there, but let's look at the alcohol first. It would be CH2. This would be having OH. And CH, CH3, CH3. So which alcohol is this? 1, 2, 3, 4. This is butanol. So that's definitely there. We need propane-2-ol, not butanol. So A is not the correct option. Let's look at B. For B, again using the same method before ester bond. The part before ester bond gives us the acid. CH3, second twice, CHC. Which acid is this? 1, 2, 3. This is propanoic acid. Let's draw it to have a more clearer idea. Now that we look at it like this is not propanoic acid. This is 2,2-dimethyl ethanoic acid. So B cannot be an option. What about C? C is the part before ester bond gives us CH3, CH2, COH, which is propanoic acid, and the part after ester bond gives us the alcohol, which would be CH3, CH3, this part, H, OH. So this is propane 2-ol. So this follows. C is the right answer. Let's do part D to be sure. This part will give us the ester, which is CH3, CH2, CH2, COOH. This is clearly not propanoic acid, so D is wrong. Section B. An isolated gaseous atom of element X has paired electrons in at least one of its 3d orbitals and has a filled 4s subshell. What would be the identity of element X? So let's write out the electronic configuration of iron. 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d6. So it has clearly more than one 3d orbitals filled and 4s subshell filled. You have to pay attention to this part. So iron is following what the question is saying. Gallium. Now for gallium, the configuration would be, I'm just writing the last part, which is 4s2 and 3d10. Since gallium has 31 electrons, you can use the periodic table to find this out. So this, according to this part, gallium is also the right option. Copper follows a exception. Make sure you memorize it. That copper, I'm not going to write this part. It is the same. Copper has 4s1 and 3d10. Since there is an exception that when 3d orbital is near half or full, it's either 4 or 9, then it takes one electron from 4s and becomes half or fully filled. So in copper that is being done. It does there one electron is been taken by the d orbital, 3d orbital, and it has become 10, and this has become 1. So copper is not following what the question asks, which is filled 4s subshell. Hence it is not filled, it is lacking one electron, hence the copper would be wrong. So the answer would be B. You can use this key to find out the correct option. Since only 1 and 2 are correct, B is the right answer. Which allotropes of carbon have a giant molecular structure? So you need to memorize this, that only diamond and graphite have a giant molecular structure. This doesn't have. It has a simple structure. Okay, so then this would be, according to the key, C. Which statement about endothermic reactions are correct? On the reaction pathway diagram, the products of the reaction are lower than the reactants. That's not true. This is true for exothermic, not for endothermic. There is a net transfer of heat energy from the surroundings to the reaction system. This is right. Always heat energy is absorbed in endothermic and released in exothermic. The total bond energies of the reactants is greater than total bond energies of the products. That is right, because the diagram is like this. So the bond energies of reactants is greater than bond energies of the product. Make sure to memorize the last point because many MCQs come regarding this. So C is the answer. The rate of chemical reactions can be increased by the addition of a suitable catalyst. For which reactions can a heterogeneous catalyst be reused? So heterogeneous catalysts are mostly metals. Nickel is used in Haber process, so that's a heterogeneous catalyst, and vanadium 5 oxide is used in the second one, so that's also a heterogeneous catalyst. And lastly, nitrogen oxide acts as a catalyst, so 3 is also right. No, sorry, there's a mistake. Actually, in this reaction, monoxide is not acting as a catalyst. Here, the catalyst used are rhodium and platinum, liquid platinum, right? So 3 is also following. These all, whatever the catalysts are used in these, they are in the different phase from the reactants. As you can see, these are metals, these are solids. Right, so the answer is A. Which chlorides, when added to water, can produce a solution of pH less than 5? So that's silicon chloride, aluminum chloride, magnesium chloride, not. It produces a solution of pH 6.5. So the answer is B. Acid rain continues to be a problem. Which statements about acid rain are correct? Acid rain is formed when oxides of nitrogen or oxides of sulfur react with water in atmosphere. That's right. Acid rain causes an increase in the concentration of heavy metal ions in water courses. That's true. Nitrogen dioxide will catalyze the formation of SO3 from SO2 in the atmosphere. That's also right. The equation is this. Which compounds contain a chiral center? 2-hydroxybutanoic acid. So let me draw them. 2-hydroxybutanoic acid would be this is one. This is our second one. This is the third one. 4. Now let's see the chiral centers. I'm not drawing hydrogen atoms. Make sure that you draw them so you don't get confused. So is there a, this is the chiral center, right? And here, this is the chiral carbon. In the third one, there's no chiral carbon. So first and second, B. The diagram shows the monomer used to make PVC, assuming that one particular molecule of the polymer forms from n molecules of the monomer, okay, where n is many thousands. Which statement is correct? The relative molecular mass of the polymer molecule is approximately 62.5 n. This is actually true because the MR, if you calculate of just this, there are 3 hydrogens, so 3 plus 2 carbons, so 12 into 2 plus 1 chlorine, 35.5. This gives us 62.5, and since there are n number of molecules, so 62.5 n. So 1 is right. There are n chiral carbon atoms in this polymer molecule. So the chiral carbon would be this one. So it's only 1 in this whole molecule. So there would be n number of chiral carbon in n molecules, because since there's only 1 in 1 molecule, there would be n in n number of molecules. So 2 is also right. Now the third is there are 5 n sigma bonds in one polymer molecule. This is actually wrong, because let's take an example of a molecule. So let's draw. Now, for example, this shows 2 molecules. No, this shows only 1 molecule, only one part of a polymer, right? So let's count the sigma bonds. According to this formula 5n, there should be 10n, right? There should be 10, actually 10 sigma bonds. Let's count if there are 10 sigma bonds. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. There are 12, meaning this option is not being followed. So the answer is just B. An organic compound X has the following skeletal formula. Okay, which statements about X are correct? X is a primary alcohol. That's true, because the hydroxide group attached to the carbon is only attached to one other carbon. X will dehydrate to give a single alkene. That's true. When it is going to be dehydrated, it is going to give this alkene. There's no other option. X will undergo a substitution reaction with chloride ions. That is true, because it is going to go under substitution. Why substitution? Because since there are only single bonds, it can only go under substitution. And as haloalkanes do form from primary alcohols, the preparation of haloalkanes is done. So this is right. 2,2,4-trimethyl-pentenyl is used in the manufacture of adhesives. Which reagents would 2,2,4-trimethyl-pentenyl react with? Okay, so these are the reagents listed. Let's first draw the structure of this. This would be pentenyl 5 carbon. At the end, pentenyl, the aldehyde functional group, and trimethyl 2,2,4. So 2, there are 2 methyl here, on second carbon and on fourth carbon. This is the structure of this. Now let's see if it is going to give a PPT with 2,2-D and pH first. Let's see. Okay, so 2,2-D and pH only, it reacts with both aldehyde and ketone. So there is a aldehyde functional group. So it is going to give a PPT with 2,4-D and pH. And now let's look at Tollens reagent. Tollens reagent reacts with aldehydes only. And there is a aldehyde functional group in this. So Tollens reagent is also going to be the answer. Alkaline equacidine only gives PPT with either primary alcohol, sorry, not primary, secondary alcohol, or ketone bonded to methyl group, or ethanol ethanol. Alkaline equacidine gives a test with these 3. Since there are none of these are present in this, so 3 is not going to be considered, and the answer would be for 40B. That's all for this paper. I'll see you